On page 17, we compare two different investments, okay, two options, and we found out that we were using the same interest rate for both, but we had different compounding periods, right? We've got monthly for the option one and semi-annually for option two. And we ended up realizing that if all else is the same, like if we're investing the same amount of money, if we have the same interest rate, we want the highest number of compounding periods to get the most money, right? So this is the better option here. Okay, so I want you to add that in your notes. All else equal, a higher number of compounding periods is best, okay? That is from an investing perspective. If you're borrowing money, what do you think? If you're borrowing money, would you want the highest amount of compounding periods like that the bank uses? The lowest. It's the exact opposite when you're borrowing money. Yes. Okay? Because otherwise now your debt is going up higher at a faster rate. Okay. For B, we're going to do B for both of them. Okay, it's asking us for the interest earned. Remember, interest is always future value minus the principal. Can we, hold on. Turn it down. Okay. So we want interest. Interest, we will take the 235,048.92 minus the 150,000 that we originally, this is the original amount, it's called the principal, okay? So we basically just subtract them to get our interest. And that is 85,048.92. The interest here this is always true, folks. If you know the future value and you know the principal, you can just subtract the two. It doesn't change. So here we earn 84,000. So this is an extra step you have to take if you want to find out how much has been earned, right? How much interest you've earned in that particular investment. C, for rate of return, we go I'll give you a shorter version of rate of return, folks. It's A minus P over P times 100, in a sense, right? How much you have accumulated minus how much you started with, divided by how much you started with. Yeah?
So can't you just take like the interest and put it on top?
Yeah. So if you catch that exactly, this is the interest, right? This is how much you've earned. So if you just want to use that number, plug it in there and then divide it by 150,000, you're good to go. So I'm gonna use that. I'm just gonna put that number right next to this, okay? That's 56.70%. what will happen down the road is that you're gonna have to be a bit more careful because you're not just gonna put in one amount one time. You're gonna keep investing. You're gonna put down money and then you're gonna put more in every month or every week. So now you have to be careful with figuring out how much you put in, okay? Times 100, you get, I get 56.05%. And I cheated a little bit. That red, what's written in red is basically what answers D. What can you conclude about compounding periods and the effect on the future value? That if all else is equal, like if everything is the same, a higher number of compounding period is best. There'll be a faster growth, right? It'll result in a higher return. So this is D here, just so you know. Okay, I'm going to skip to 20. I'm going to leave the rule of 72, which you're looking at on the next page. I just want to give you a different scenario of the compound interest formula. Go to page 20. What is page 20 all about? Is solving for the principal when the compound interest formula is required, okay? Okay. When are we using compound interest formula? How do you know we're using the compound interest formula? What's a key word that you're looking for? Compounding periods, right? Or compounded. So if you see that, right? For example, Zach has accumulated 45,000. You keep reading. It says compounded daily right there. You cannot use simple interest formulas. Okay? So you know you're in a compound interest scenario. I know this is hard to grasp sometimes because you're not into investing yet. Maybe some of you are. What's the difference between compound interest and simple interest? Like just compound is exponential and the other one is linear. Which one? So simple interest is linear? The other one, yeah. Simple interest, you earn interest on that initial principal. That's it. It's always back to the original principal. Like if you put 10 grand in, it'll be always based on the 10 grand, on the 10 grand, on the 10 grand. Compound, it's 10 grand that you deposit, you earn some interest the first year, and the second year, you're going to earn interest on that interest you've already earned. On the third year, you will earn a bit more interest on the interest that you've already earned. So it's like a compounding effect. Okay? That's why they're different. But if you remember the linear and the exponential, you're doing pretty good. So I'm going to use this formula. Okay? Remember this one? It says Zach has accumulated 45,000. This is A. Okay, 45,000 is what you've accumulated. Time is already in years, so perfect. We are earning at a rate of 3.99. That's R. Compounded daily, that's N. We've got everything we need. So the 45,000 will go in for A here, 45,000. We don't know what P is. That's what the question is asking, right? How much did he start with? What was the initial amount? Can you write down, it's like, that's basically asking, what's the principal? Right, what's the principal? So 1 plus, I already turned that interest rate into a decimal. You divide it by compounded daily. That means 365 to the power of 365 times my time in years, okay? time in years is 3.5. That's actually, you're supposed to come up with just one number when you're all said and done. Please don't rush this one. Resist the urge to just get it all into one number. Resist that, okay? So you grab your calculator, and I would say turn this, divide that by 365 first, this part, because division comes before addition. And then you go plus 1. That's 1.0001 something. Okay? And then we're going to go 365 times 3.5. That's 1,277.5. Don't round. Okay? What would your gut tell you to do now? See how there's a number here and you've got an exponent attached to that number? Figure out what that is. Okay, figure out what that is. So I'm gonna do this part. So I'm gonna copy paste. I'm gonna go get that answer. I'm gonna raise it by using the hat, right, to that exponent. And you get that 1.1498 something. Now that you cleaned up the right side, now you basically just have a number multiplying p. That's when I divide both sides by that number. Cancel that out. Principal is 45,000 divided by, I'm going to copy paste, 39,135.12. Okay. So now you figured out how much you started with. So the only difference is that you don't know what the principal is, so you do the work, as much work as you can on the right side, and then at the very end you divide both sides by whatever you end up with here to get the principal. And you should start with less than what you end up with. Okay? If you get a number here and it's 50,000, you go down to 45, that's not a good investment. You lost money, right? So keep that in mind. All right. Why don't you try a couple here? I'm going to say page 24. And I will give you some of the answers so you know what to expect, okay? Go to 24. And just look up here real quick. The first two is just basic compound interest formula, like we've done yesterday. When you get to 6, then you are applying what we did just now, okay? But I want you to work on this. Work on page 24, because I will move on to that app that I was talking about. Here are the answers. By the way, everything up to C and D, they want the final amount and the interest. The final amount is $29,050 and 53 cents, and the interest is $11,050.53. This one, A is 94,882. I is 9,882.85. So write down those answers. For 6, I'm going to give you 6A already. It's 11841.14. Let's see if if I can fit in that last one there. That answer is $50.81. It's a very small amount, but hopefully that helps you. So this is your chance to try it. I'm going to walk around and make sure you know what you're doing before we move on, okay?